Hi everyone. So sorry about the colors. Apparently we have some issues with my Mac and the screen, and so it's not as bright as it should be. But at least that won't like wake you up on a Friday afternoon. But anyway, I thought I would start with a short story because I'm going to talk about how to build a performance measuring tool. But the question you might ask is like, why in the world would you want to do that? So a long time ago, when I was a junior developer. Probably still had more hair on my head. I worked with a client and they were really good. Like they had a really strong technical expertise. And I thought, wow, that's going to be so good because I'm going to learn so much from them. And for example, they had a lot of technical standards about everything. And on the subject of performance, for example, they had a lot of measurable performance requirements. So one of those, for example, we were building a web app and a mobile app. So on the web part, they required us to have a 90+ Lighthouse core for desktop on every web page. So if you don't know what Lighthouse is, I just quickly Googled it, and evidently Google does not know me at all. I'm not talking about the movie. I'm talking about this tool in Google Chrome that you can use to basically generate a performance report for any web page you want. Just in a few clicks, even if you don't own the web page, you can basically get a performance score out of it, which is pretty cool. So being a mobile app developer myself, I was really curious what they were going to tell me, like, oh, what are they going to say is their measurable performance requirements on mobile? And they just told me, well, the app should not lag, which is, not very measurable, right? So I thought to myself, wow, this is interesting. I was really searching for a clear and efficient way to know, like measurable scientific way to know if my app has a good performance. And I kind of dived deep in the subject and began having an expertise in performance. And well, hi, I'm Alex, and this is how I became the performance expert at a company called Theodo Apps. We develop mobile apps based in Paris, London, and a lot of other places. But coming back to that question, I started to search for an answer, and I came across this video by Google a long time ago saying, well, your app should run at 60 frames per second. Obviously, nowadays we have actually phones that can do better than 60, but okay, to have your app being fluid, 60 FPS. Okay, that's already a good start of a measure. But is that enough? The thing is, I dabbled a lot with React Native, and some other metrics like CPU usage can come into play. Because, for example, if you don't know about React Native, on React Native you have your UI thread displaying the app stuff, but you also have a JS thread that's handling all the business logic and click events and stuff like that. So, for example, if you run expensive calculation on that JS thread, technically your app will run at 60 FPS because the UI thread will still continue, but still your app will be blocked. So, for example, here I click the Click Me button, but then I run an expensive calculation and the app is unresponsive. Right, let's do that again. Click me, okay, it works, but kill.js, and then I cannot do anything anymore until kill.js has finished. And yeah, going back to it. So technically, this app runs at 60 FPS, but does it have good performance? Not really. Also, just talking about maybe being a bit green about our apps. Of course, if your app runs at 60 FPS, but is also burning down phones in the process because it runs at full CPU capacity, can we say your app has good performance? Maybe not. All right, all of that to say that performance is a complex topic, lots of different metrics come into play, and at some point, I ended up building a tool called Flashlight. The joke being that Flashlight is kind of like, Flashlight is kind of a pocket lighthouse, a mobile lighthouse in a way. So if you go to flashlight.dev, you can upload an APK and get a performance score out of it. It's also open source. You can also generate comparison reports, which I think is pretty cool. I like nerdy performance graphs, so I'm really happy with it. But at the root of it, Flashlight, what I really wanted to have was to have something like Lighthouse. So something with no setup required in your app, basically being able to measure any app, because being able also to measure release apps, and ideally tech agnostic, because we actually do at Theodo React Native, and Flutter, so we can have a bit of battles between like, oh, what is the most performant technology and all that. So I thought we would do a bit of live coding and see how we can actually recode that in, well, 30 minutes and hopefully a few lines of code. So we'll start actually in the terminal, and then we'll go to some live Kotlin. I'm showing up my really impressive Keynote skills. I just discovered Magic Move and Keynote, so I'm having fun with it. All right, so we need first to talk about ADB. So I'm sharing the screen from my phone here. And yeah, I have like really stupid screenshots. So ADB is, of course, the Android debug bridge. You've probably used it to install APK, uninstall APK, etc. This is how you communicate with the device. Because the first question we need to answer is, can we actually measure the performance of apps in production? Like in Android Studio, your app needs to be profilable, right? You cannot like take any app you want, like Twitter or whatever, and measure the performance. So ADB is really cool. You can do a lot of stuff. One of my favorite comments is that you can just do ADB shell input text and add some text, and it will print the text. I do type my passwords like that sometimes. But what's interesting in ADB shell, by the way, do you guys at the back all can read or should I make it bigger? Okay, cool. What's interesting about ADB shell input text is that it starts with ADB shell. So if I just type ADB shell, I actually open a shell on my Android device, which I think is pretty cool. So for example, if I do echo bonjour in my device, I'm actually running that command on the device. Surefire way to just verify what I'm saying is I can call uname to see what the OS is. And uname actually replies with Linux. And of course, if I exit that shell and if I do uname, it replies macOS. No, it replies Darwin for macOS. So I'm running here on my Mac, but I can also do it like that, ADB shell uname. I run uname on my Android phone, which says, hello, I'm Linux. So this is really cool because it means that we can run a lot of commands that we could run on Linux OS. And so if we talk about performance, there are a lot of performance utilities that we can use on Linux that are probably available. What about top, for example? So on my Mac, I can run top, and it will display kind of a crazy screen, similarly to Activity Monitor or Task Manager if you've used some of those. And it will basically display the top program consuming the most CPU usage and a bunch of other data like memory and stuff like that. So it might be a bit hard to read, but the top one is Windows Server, sometimes iTerm, actually, the terminal, and also Screen Copy, which is the process I'm using to share my device screen. So does it work on Android? Well, let's find out. Let's just type ADB shell top. And there you go. It works. So let's have a fun experiment. I'm just going to open the Twitter app and just like scroll like a madman. And so maybe tricky to see, but at the end, at the top of it, I can see com.twitter.android, which is consuming basically 150% CPU at the moment. Ooh. Going a bit down, etc. So I'm not a Twitter developer. I don't have access to the source code. This is the release app, and I'm able to measure the performance of the Twitter app, at least the CPU usage and the memory. If you're wondering about why 150, it's because it counts 100% for each CPU core. My phone actually has 9 cores, so it can do 9 things in parallel. So the percentage could go up to 900%. Well, I mean, if that happened, probably my phone would burn down. But so 150 is not that bad. All right, so we're able to basically measure CPU usage in production. So almost done. Well, if we think about what I said about, like, for example, React Native apps with JS thread performance, or even native apps, it's always nice to have a bit more information if we talk about CPU usage. For example, to know exactly the performance of the UI thread, because we don't want to block that guy. Otherwise, we get ANRs and frozen frames and stuff like that. So can we actually get thread-by-thread information? Well, it's very simple. We can pass an option to top, and we can pass basically H like threads. I'm kidding. I was kind of puzzled the first time I realized that the option was H, because why H like thread? Turns out it's because H like hardware thread. I still think it's a bit weird, but anyway. So if I do that, I can also pass D like duration. This one works. And 1 just to make sure that I have measure every 1 second. I think the default is every 3 seconds. All right, so now we do that. I basically have the performance of all the threads running on my phone. So for example, if I open the Blue Sky app, because we talked about Blue Sky in the keynote, let's see what happens if I scroll like a madman. Boo, boo, boo. The top one is called MQTJS, going at about, oh wow, there was probably a bug there, I don't know. MQTJS going about 50% CPU usage. You guessed it, that's the JS thread. The second one is called Blue Sky Web.app. That's basically the UI thread because it has the same name as the bundle ID. And if you take a closer look, we can even see render thread. We can see a glide cache thread. It's cool because we actually can learn a lot about apps just by investigating the threads. For example, we know this app uses glide to display images. All right, so again, we can be thinking, okay, that's really cool, Alex. Basically, that's the end of the talk, right? Because we're able to measure CPU usage thread by thread. That's already really nice out of the box. Well, 2 caveats with that. First one is duration can actually not go lower than 1 second. So that means we cannot pull measures every 500 milliseconds if we want to. We don't have that kind of granularity. The minimum is 1 second. So that's kind of annoying. But the second issue, and maybe the most major one, is you might have noticed that actually top does show up in that screen. So we can actually see that the CPU usage of top is far from negligible. At the moment, it's running about 23% CPU usage. You might be like, 23, that's fine. But, well, this is a Pixel 8. It's not a bad phone, hopefully. You can imagine that on lower-end devices, or God forbid, smart TVs, which are usually really bad, but a lot of fun, it gets worse than that. That brings a really interesting topic when you try to build tools to measure performance, because usually performance measuring tools have an impact on the performance of your device, or even worse, on the performance of your apps. For example, if you use Android Studio and you record a Kotlin trace or something like that, your app will slow down, right? And if you use the RAM profiler, your RAM will actually increase. So your performance monitoring tools have an impact on the performance of your device and sometimes even your apps. So here, I wanted to have something that had a really minimal impact and that could work even on low-end Android devices, because usually that's where you see performance issues. So what would anyone with a sane mind do in that situation? Of course, they would check out the Android source code and check the top implementation and try to do the same thing. So if you're with me, that's what we're going to try to do now. Because, where's my, oh yeah, there you go. Because the really cool thing is that we can actually go to the Android open source project and just go to code and check out stuff, which is really cool, I think. And if we search for top, we will actually find the implementation for top. Well, no, actually, we will find tons of well, oops, sorry, ton of code with top in itself. So it's not a great idea to do that. But maybe we can just cheat a little bit and do adb shell top.help, just take a random wording and see if we can find anything. This time we have fewer results. I think that's the correct way to say it. We have header files, and this one seems promising because it's a C file, so it's probably implementation details, which is kind of nice. I'm going to zoom in a little bit. Maybe I can close that full screen. Oh, yeah. perfect. Your average C file with like 2,000 lines and, well, So let's try to apply maybe a little bit of guesswork. By the way, this would probably be a really good case for Gen AI to just explain to me that code. But where's the fun in that? So if we take a look at all the functions actually in that file, we would have found that there's a top main function that is probably the starting point for the implementation of top. We could have probably verified that, but let's suppose that this is it. So top main, it prints a bunch of stuff which kind of looks similar to the output of top. Then it goes to top common, all right, which does a crazy, I don't know, a lot of C stuff. I've done C, but it was a while ago, and well, I'm not so familiar with it. And try to find stuff that's interesting. Okay, maybe those two lines are kind of interesting for a few reasons. First, because there's a flag called "Dear Tree, Shut Up," which I think is really funny. But also because there's a flag here. I mean, there's the option that we passed earlier. I passed -H to see the threads. That's basically where it's used. And so what's happening here? So we use a function called dirtreeflagRead to go in the /proc file on the device. We go through every subfolder, and we apply the getThreads function. All right. Let's see what getThread is doing. I'm going to go a little bit faster. There's a bunch of stuff there, but here again we have something kind of interesting with dirtreeflagRead, and again dirtree shut up. Maybe that's why it just jumps to my eyes. And here we see that essentially we go through /proc %u, which is replaced by PID /task, and on all of those, the subfolder of /proc /PID /task, we apply the function getPS. So PID, very likely that's the process ID of our app. We'll see that in just a few seconds on an example. And getPS, what does it do? It reads from data about a process. Very cool. It seems to be reading from a bunch of files, doing a lot of crazy stuff again. And probably the most interesting file, I don't know, stat sounds like a good candidate. But that's really some guesswork. But I mean, maybe we can actually go to the documentation, because actually this is Linux, and find out what is in those stat file under /proc. So if we open that documentation, we can find it on the Linux manual page. And wait, before I do that, let's try to open one of those files actually. So if you completely dozed off at the moment because there was a lot of C code and you were like, what is happening? Please come back. And let's try to apply what we just saw. For example, on the Blue Sky app, let's find the process ID of our app. So all of our apps have a process ID. And to find it, I can do adb shell pitof and then the bundle ID of Blue Sky that you can basically find on the Play Store. So if I run the app, this is the PID or process ID of the app. So if you remember, we had basically /proc, then we had /PID, and then we had, well, under that there's a lot of subfolders, but the one that interested us was /task. Then /task, we have a lot again of subfolders. So let's just try to take one random one. And then there was the stat file. So if I do that, I can see just a single line file with lots of numbers. But what's interesting is, it seems to be, I was kind of lucky there because this, I took one randomly, but this is the render thread, which is used in native app to basically communicate between UI thread and GPU to, well, render stuff. So we do have information about render threads in a lot of numbers and also a letter. But let's check out the documentation to see what those are. So First one is process ID, sure. Second one is basically the name of the process truncated to 16 characters because, well, okay. But, okay, I'm going to do Command-Shift-F and jump to CPU. Okay. So at colon 14 and colon 15, we have CPU information. So U-time is amount of time that this process has been scheduled in user mode, measured in clock ticks. Okay, cool. Basically, this means that this is CPU time measured in clock ticks that has been scheduled in user mode. So basically, the code that you have written, but you also have S time, which is the same thing, but been scheduled in kernel mode. Basically, it's not exactly the code that you have written. It's some code that would have been called on your behalf by the OS to do some low-level stuff like draw frames, like doing I/O operations and stuff like that. So to get CPU, basically CPU usage of a process, we can just add those two columns. And they give us the information in clock ticks. But basically, we just need to know how many clock ticks are in a second, and we can basically get timings. And to do that, we just need to see what's the value of this guy here, and we can just do that with adb shell get conf clock tick, and it's usually 100 for Android devices. So basically, we can, oh yeah, and every time I do adb shell top, my cursor disappears. So I'm just going to restart the shell here. If anyone knows how to not have that, that would be really awesome, but anyway. So let's do cat, yeah, my process, and then all of the threads. Oh yeah, it's not the right PID ID. What was the correct PID? 6006. There you go. Oop. There you go. So here I basically have all of the threads inside the Blue Sky app with a bunch of numbers. Yeah, this is the crazy talk that you wanted to see on a Friday afternoon. But with that, we should be able to get all the information we want. So I'm not so great with Bash and stuff like that, so I thought maybe this is the time where we move to the Kotlin space. And so I started a little bit just to be fast, and I started with a Kotlin script because why not? Just to essentially run exactly the same command. And so let's execute it with Kotlin perf and then my PID, and I should have exactly the same result. Yeah. So at the moment, it's just doing adb shell cat, the same thing, and it gets the line for all of those, so one line per thread. So, all right. So what we're going to do is we're going to go on thread stats, which is the output of the command. We're going to get the line. Is it big enough at the back? By the way, can you read? Yeah. I'm going to just filter the lines that are empty. And I'm going to map it to... Basically, whoop, doing too much JavaScript sometimes. I'm going to get the colons of each line by doing a big split. And here I will type the regex with a snippet because I don't want to have to live code that. And this should give us basically all the colons that we saw described in the Linux documentation. So then we can get the PID first, which was colons of 0. Then we have the name, which is colon of 1. And we had utime, which was the 14th colon. So there you go. And we had stime colon of 14. And so we can basically do CPU usage equals utime plus stime, sorry. Actually, let's convert those to numbers. That would be probably a bit better. All right. So I'm going to store them in a data class, right, just a measure class with ID name and total CPU usage. And Oh, I chose not to have Copilot here. Cool. Copilot makes me really lazy. Or well, AI in general, I guess. Total CPU usage equals CPU usage. All right, so those are basically the current measures that we have. So if you want to try that out, let's, for example, just sort by descending and... did I mess that up? Huh. I think my syntactic... Oh. Did mess that up. Oh, there you go. Wow. I think Android Studio is not helping me out, but oh well. I'm going to take, basically, I'm going to sort them down by total CPU usage and take the first one. And then for each one of those, I'm just going to print the name and the CPU usage. Name and the total CPU usage. All right, so let's go. My terminal is here. I'm actually going to... And, oh, I could have done println. Would have been a bit nicer, you know. All right, so we can see now that basically this is the main thread because it has the same name as the app ID. I can actually make that a bit bigger now because we don't have so much thing to say. Let's do that again. So the first one was the main thread because it has the same name as the app bundle ID but truncated to 16 characters. Second one is the JS thread because, well, this is a React Native app. Then we have render thread because, well, it's still a native app and doing all that stuff. And this is the CPU usage measured in clock ticks. Okay, still not so fantastic. But we can display those measures every second or every whatever we want. So let's add a timer. And let's do every second. But I mean, we can do every 500 milliseconds now if we want to. It's just a bit nicer if we do that. And let's just do display CPU measures. And maybe let's also clear the console, right, every time we do that. So now... let's see what happens. All right, so now every time I move in the app, I see those numbers increasing because this is a total CPU usage of all of those threads. So it would be a bit more interesting if we could see basically every second, like what was the actual CPU consumption during that second, so we can basically get a percentage, right? That would be a bit nicer. So to do that, let's just store previous results in a map. So previous thread CPU usage equal, let's do a map, let's do it string long. So basically what we're going to do is at the end of my function here, for all of my measures, I'm going to loop through them. And I'm going to say previous thread CPU usage of measure the thread ID. Yeah, I forgot to, let's just call it it. Its ID equal its total CPU usage. Right. That way, I'm going to basically be able to do something, basically saying like my new measures, my live measures, sorry, are current measures dot map. Whoop. Wow, I'm really bad at live coding. Okay, my previous CPU usage would be previous thread CPU usage, the one that we stored, right? And measure.id. Let's fall back on 0 if it's not there. Use F. So then my current CPU, I mean my live CPU usage, kind of, or let's call it CPU usage diff, will be measure.total minus previous CPU usage. And so I'm just going to yeah, I'm just going to create another data class also with a snippet just to store name and CPU usage diff. There you go. Just to store that live measure with name equal measure dot name and CPU usage diff equal CPU usage diff. All right. And then we can do the same thing, live measures dot, let's sort them out by CPU usage diff. Let's take the top 5 and let's display something, println it.name and then it.CPU usage diff. Also, let's clear the console. All right, let's try that out. So now I have basically live performance measures. Actually, you might have noticed something kind of weird that the first time essentially we see, well, of course, our map is not filled out yet. So the first measures that we see is, well, we have nothing. So we display total CPU usage instead of what has been consumed during a second. So let's just fix that and say, like, if it's the first time that we're running, we just need to say, oh, if the map is empty, we basically won't display anything. And actually, if we want to display it in performance, we would need to divide it by the number of CPU clock ticks in the interval that we chose. But since the interval that we chose is a second, and we have 100 clock ticks in a second, basically, this is already a percentage, just to be fast there. All right, so let's see what this gives us.
It's not the first. It's not the
Nope.
first.
Right? What? What did I do?
If it's first row.
Oh, right. It was just to see if you follow, and you guys are really good. Yeah, you can actually applaud yourself. All right, so there you go. And here I can basically just scroll down and I see live CPU measures, thread by thread, of any app I want. I can just quit this one and go to Twitter and do the same thing, essentially. So that's pretty cool, I think. And this is basically how Flashlight is implemented, kind of. I mean, it has a better implementation than that, but that's basically the gist of it for CPU. Do I still have time for FPS? I think I still have 5 minutes. So let's talk about FPS, because it's a lot of fun. So with FPS, we can actually use another ADB shell command called atrace. If you have ever used Perfetto, it's a really good performance profiling tool, very powerful. It actually kind of uses atrace under the hood. What's really fun about atrace is that, well, let's run it and see what happens. Well, actually, I'm going to run it on a very simpler app. So, OK, an app just using a fade in and out animation. And atrace will actually display to me at a very low level on Android all of the functions that are called, which is kind of crazy. So we see lots of function about like rendering engine and stuff like that. And again, this is a really fun talk to come to just see a bunch of numbers, crazy lines displayed on the screen. But what's really, really fun is that at the lowest level, to display frames, Android will call on a class called choreographer, it will call a function called doFrame. And that's basically the root of like, you know, the building a frame is calling a function called doFrame. And of course, it does a lot of stuff there. But we can be a bit naive here and just say like, oh, if we want to count frames, we can just count calls to choreographer, choreographer.doFrame. So let's just do that. By the way, this application is kind of stupid because, for example, if I click on that button, I'm stopping the UI thread and the animation stops. So it's just going to be an easy way to see if our code actually works. So just to be a bit faster here, I'm going to directly use a snippet just to basically execute ADB shell atrace. and then read all the content. So again, it's going to be completely crazy output. First, I need to find the process ID of this new app, which is this one. And then let's run again. And, whoop, that's not supposed to happen. OK, let's do it again. I'm just going to do a crazy ADB trace comment. Yeah, maybe. OK. Will it work? OK, yeah, that's just what I wanted. It's just reprinting all of the lines from trace, reading them, and, well, we can do whatever we want. OK, it's some really stupid and not very optimized algorithm, but it's just to show you the principle of what we can do. Because, like, we have a while true and everything, it's fun. So here, on each line, we're just going to check if line actually contains choreographer.doFrame. And very important, we also need to know that this line is mentioning our process ID, because otherwise we're going to count all the do frames from all of the apps on our phone, and that include, for example, the status bar. So we would see actually a lot more frames than we want. All right. And we're going to do something kind of stupid. I'm just going to do a current frame count here equal to 0. So I'm going to increase that. And to go every second, I'm going to do something really, really stupid and do last print time equals system dot get current time millis. And I'm going to do, oh yeah, don't hate me for it. It's going to be a lot of fun. Val current time. Yeah, I'm sure some of you are guessing what I'm going to write, maybe. Current time milliseconds. I'm just going to say if more than 1 second has elapsed, I'm just going to print the number of frame, right? So a bit insane, but it's just to show how, what we can do. All right, so here I'm just going to print frame count and reset it to 0 and reset last print time to current time. And there you go. Let's go back here. All right, if all goes well. Oh, current. Oh, yeah. Wow. Cannot code without syntax coloring. Huh? OK, there you go. My phone actually runs at 120 FPS. So this is quite reassuring. We see some numbers that look a lot like 120. Of course, our code is not really accurate because it's a kind of a dumbed-down version. And if I click on run expensive stuff, I go down to 0, and then I go back to 120. So there you go. Basically, in 30-minute-ish, we got CPU measures of app in production, and we got FPS. So just a quick go back to the slide, but this is basically the last slide. If you want to know more about this, you have a QR code containing a link to the Kotlin repository, the Flashlight Lite version. You have also the real Flashlight link, and you have also the slides. And you can also leave feedback as easy as clicking some buttons to say, like, oh, this was a total snooze fest, or oh, this was good. I really appreciate all the feedback you can give. So yeah, there you go. But yeah, just to mention that, yeah, performance measures are crucial, but of course complex. But Android and Linux actually gives out a lot of power out of the box. So I hope you guys had a lot of fun with me diving deeper into a lot of stuff that we probably know, but I don't know if you guys had ever read some C code in the Android source code, but there you go. Thanks a lot for your attention. And I'm probably, end of time, so if you want to ask any questions, just come and see me.